We're going to cover evaluating integrals that involve trig functions. Or trig inverse functions. Okay. So this entire class is really going to revolve around three formulas. Okay. So you have the integral of du over the square root of a squared minus u squared, equals sine inverse of u over a plus c, and of course that means u doesn't equal a. The second formula, the integral of du over a squared plus u squared, which is 1 over a times the tangent inverse of u over a plus c. And let me bring that down a little bit. And the integral of du over the absolute value of u times the square root of u squared minus a squared equals 1 over a times the secant inverse of u over a plus c. And again, u doesn't equal a. And u can't equal 0.
Is the second one supposed to have a square root, or is there no square root for that?
Nope, no square root on the second one.
Okay.
Yeah. Okay. Now the reason we only have these three is because for the sine inverse, the only difference between the sine and cosine inverse is the cosine is negative. So in order to avoid having you memorize 6 formulas, you just have you memorize 3. So since, let's say negative du over the square root of a squared minus u squared, and I could put the negative inside there, equals cosine inverse of u over a plus c. Instead, we'll just have you write it as the negative of sine. So this way you don't have to worry about remembering the cosine. So let's say I'm going to go to negative du over the square root of a squared minus u squared equals negative sine inverse of u over a plus c. Okay. Kind of takes away having to memorize that at all, which you don't want to. Okay. So instead of 6 formulas, you only have 3. The tangent, the difference between the tangent inverse and cotangent inverse, is just a negative sign. So we'll just write it as a negative tangent inverse. Same with secant and cosecant. The only difference is a negative sign. So, Oh, sorry about that. All right. So any questions on that so far? All right.
Signs are that it can't equal, right? Not plus or minus. I don't know.
Which one?
The, like,
Oh, this
I
one.
think I'm reading, yeah.
Oh, yeah, that's can't equal.
Okay.
All right.
Would the same,
Hmm?
would the same be said for tangent?
Yep, with tangent,
Or
if,
you can't equal 0?
yep, just can't equal 0. I mean, u can't equal a, rather. No, actually, with that one, you don't need one because negative u and negative a will always be positive, so they won't cancel each other out. So that's the only one with no stipulations.
Well, wouldn't you still,
Hmm?
Because there's a 1 over a for that? Or no, that's it's talking about u.
Oh yeah, a is just a constant. So if you, yep, you don't have to worry about having like a zero constant.
Okay.
All right. Any other questions? All right. So we'll start off by proving the first one. Okay. Some of you may remember this from trig. Let's say if we let y equal sine inverse of u over a. Then if we apply sine to both sides, remember the sine and the sine inverse cancel out. Let's say sine of y equals sine inverse of u over a. All right, those cancel each other out. So you're left with sine of y equals u over a. Multiply a on both sides, and you end up with u equals a sine of y. Okay, well, I'm just going to switch that back over. A sine of y equal u. If we differentiate both sides with respect to u, we end up with a derivative of sine of y is cosine of y. But it's with respect to u, so we're using implicit differentiation. So it's dy du equals the derivative of u is just, with respect to u, is just 1. Right. So from there, just divide both sides by a cosine of y. So dy du equals 1 over a cosine of y. Okay. Now we know the Pythagorean identity, which we've used a million times before, hopefully. Which is sine squared plus cosine squared equals 1. Okay. So if we just subtract sine squared from both sides, cosine of y is equal to positive or negative 1 minus sine of y, well, sine squared y. Okay. Now we know cosine of y is positive from negative pi over 2 to pi over 2, so that's the interval we're going to kind of work with. So we don't need the negative for this one. Since cosine of y. All right, so now we have this very same formula. Dy du equals 1 over a, and instead of cosine y, square root, make sure, yeah, 1 minus sine squared of y. Okay, so that means we're going to end up with, if we let a equals square root of a squared. Oops. Okay, so if we let a equal square root of a squared, then we have square root of a squared times square root of 1 minus sine squared of y. Okay, so once you have two roots that are the same index, that have the same index, you can just multiply them. So that means you can multiply that square root of a times each one of those terms. Okay, so
Move it up a little bit.
oh, sure. There you go. Okay, so you have square root of a squared times 1, which is just square root of a squared, minus a squared sine of y squared. Okay, so if you remember, right at the very beginning, our u is equal to a sine of y. So this a squared sine of y squared is just a sine of y squared, which is basically just our u squared. So it's equal to the square root of a squared. Oh, bless you. Oh, pretty good, pretty good. Minus u squared. Sorry, dy du.
1 over square root.
Oh, 1 over, thank you. All right, so let me slide this up. If we integrate both sides with respect to u. Okay, we end up with y is equal to the integral of 1 over square root of a squared minus u squared with respect to u. Okay. So we already know that our y is sine inverse of u over a. Okay, so our sine inverse of u over a, and you can say plus c, is equal to the integral, you can say 1 over square root, or you can just put it du over square root of a squared minus u squared, which is how we got the formula. And the others are pretty much the same way. All right. So any questions on that one? All right. Leave that up for a little bit. Okay. So the proof will take a whole lot longer than actually using the formula. Oops. All right, so let's say, for example, we wanted to evaluate the integral of dx over the square root of 1 minus x squared.
Move it down.
Oh, yeah, there you go. Turn this way so I can keep an eye on that. Okay, now for this one, you notice just how much it looks like the sine formula? The integral of du over the square root of a squared minus u squared equals sine inverse of u over a plus c. So all we'd have to do here is just get our original and rewrite it. So instead of 1, make that 1 squared. And make that x just x squared. Okay. So we know here that our a is equal to 1. And our u is equal to x. Okay. So if our u is equal to x, it means our du is equal to dx. Okay, so we have our a, our u, and our du. All right. So we just get our original equation and we make our substitutions. Okay. So our dx is just du. Over the square root. Remember, your a is equal to 1, so that's your a squared. Your u is equal to x, so that's your u squared. Okay. So we know that's just sine inverse of u over a plus c. So once we plug in our u and our a, sine inverse of x over 1, which is just x, plus c, that's your answer. Oh, slide that up a little bit. All right. So any questions on that one? Yes.
So when you use this equation,
Mhm.
formula, the a is always the constant and the u is the variable.
Exactly.
Okay.
Yeah. Now the u sometimes changes up to be different functions of x or t or whatever, but the steps are pretty much the same. Yes.
I was always going to be giving us such an easy form to distinguish.
As long as you know how to view the 3 different forms, and you can say, okay, which one does it look like, then all you have to do is just pull those out.
Is there ever going to be one where there's no denominator and numerator, where it's all just like x to the negative 1? Like we don't have to switch anything around. It's all going to be in this format.
The most you'd have to do is probably factor out from the numerator,
Okay, cool.
but that's about it. And I'll show you a few examples of those.
Pretty easy.
All right. Any other questions on this one before I go to the next one? All right. Okay, so let's say, for example, we wanted to evaluate dx over square root of 25 minus 4x squared. Okay, so for this one, I'm just going to rewrite it. Okay, so you have the integral of dx over, instead of 25, we'll make that 5 squared. And instead of 4x squared, we'll make it 2x squared. So sometimes you just have to tweak it a little bit. Okay, so we know here that our a is equal to 5, and our u is equal to 2x. Okay, so we differentiate both sides. Our du is equal to 2 dx, which means our dx is equal to 1/2 du. Okay, so we have our a, we have our u, and we have our du, basically. All right, so all we have to do now is just substitute where we have to. All right, so let's say if we have our equation, we know that dx is equal to du over 2. So instead of du over 2, I just write it as 1/2 du over the square root. A is equal to 5, so we have our a squared. Our u is equal to 2x, so we have our u squared. Okay, so we have everything plugged in. Okay, so I'm just going to get that 1/2 and bring it out to the front. A squared minus u squared. Okay, so we have the perfect formula. Okay, so it's 1/2 sine inverse u over a plus c. So once you plug in your u and your a, you're all done. Sine inverse, and our u is 2x, and our a is 5, plus c. Oh, move that up a little bit. All right, you're all done. All right. Any questions on this one? All right. Okay, so let's do another one. Make sure everyone's done. All right. All right, so let's say, for example, we have the integral of -2 over square root of 100 minus 9t squared with respect to t. And we want to evaluate that one. Okay, so the first thing I always do is always just rewrite it. That -2, just bring it right out to the front. And that dt, I just put it right up top. $100, that's just 10 squared. 9t squared, that's just 3t squared. Okay, which means we have our a, and we have our u. Okay, so all we need is our du. Differentiate both sides. Du equals 3 dt, which means our dt is equal to du over 3. Okay, so right now we have everything we need. All right, so we just get our original equation. And don't forget your -2. Your dt, remember that's du over 3. Or you can write it as 1/3 du. Okay. Square root, we have 10 squared, so we have our a squared. Minus your 3t squared. That's your u squared. Just get that 1/3, bring it right out to the front. So you have -2/3. The integral of du over the square root of a squared minus u squared. All right, which is the perfect setup for just plugging in our solution. So sine inverse of u over a plus c. So we plug in our u and our a, and we're all done. Our u is 3t, our a is 10, plus c. And that's your answer. All right, so any questions on that so far? All right. Do one more. I'll leave that up for a bit, see if anyone's still writing. Okay, so let's say, for example, we wanted to evaluate the integral of 4 over the square root of 9 minus 81t squared. And I'll give you a few minutes to start on this one. dt. Actually, I'll put a second one up there and you can get started on that one. And that clock is about to run out. I'll